In this lesson, the target states I can apply the properties of exponents to simplify expressions. So we're going to be using three different properties to simplify expressions of different forms. For example, when you're multiplying powers that have the same base, like 3 to the 5th times 3 to the 8th. Since they have the same base, you can simply add the powers. So it's 3 to the 5th plus the 8th, or 3 to the 13th. So let's take a look at an example of why that is. So if I expand this expression, 5 to the 2nd power is 5 times 5, and I'm multiplying that by 5 to the 3rd power, which is 5 times 5 times 5. So I could multiply 5 times itself 5 times. But an easier way to write repeated multiplication is to use an exponent. So 5 to the 2nd times 5 to the 3rd could be simplified and written as 5 to the 5th. So in other words, when we have the same base, we take the exponents and add them up. 5 squared times 5 to the 3rd is simply 5 to the 2nd plus the 3rd power, which led us to 5 to the 5th. 2 plus 3 is 5. So if you look at this algebraically, a to the 4th times a to the 6th. A represents the same value, although it's a variable, but all we have to do is add the exponents. So it's simply 4 plus 6. So a to the 4th times a to the 6th is a to the 4th plus 6, or a to the 10th. So if we were looking at it like this, and the variable this time was also in the exponent place, b to the m times b to the n is b to the m plus n. We're adding the exponents. In the next property, we're dividing powers that have the same base. So what happens if you're dividing two numbers that have powers in them, like 10 to the 4th divided by 10 to the 2nd power? To divide powers with the same base, keep the base and subtract the exponents. So this time we're going to do the opposite. We're going to subtract. So 6 to the 9th over 6 to the 4th is 6 to the 9 minus 4 power, and 9 minus 4 is 5, so it's 6 to the 5th power. Let's take a look at why that is. So if I have 10 to the 4th over 10 squared, this is 10 times 10 times 10 times 10 if I expand it, and in the denominator it's 10 squared, so it's 10 times 10. Anytime I have 10 over 10, it would cancel out between the numerator and the denominator. So I would multiply everything on top and divide by everything on the bottom. So 10 divided by 10 cancels out, and 10 divided by 10 cancels out again. So I'm left with 10 times 10, or 10 squared, over 1. So 10 to the 4th divided by 10 to the 2nd is 10 to the 4th minus 2nd power over 1. So it's 10 to the 2nd. And I don't need to write over 1. So when the numerator has a power that's higher than the power in the denominator, you end up with a number on top, 10 squared over 1, or 100. You could simplify this further and write 100. But what happens when you have a number in the exponent place that's bigger than the number in the exponent place in the denominator? So let's take a look at how this would expand. It'd be x times x times x over x times x times x times x times x. Need one more x times x. Squeeze that in. Well, anytime I have x over x, it's going to cancel out. So this x and this x would cancel, this one and this one and this one and this one. So what I'm left with is on the bottom this time. So this one would be 1 over x to the 3rd power, because this x times x times x is x to the 3rd power, and what I have left on top is 1. So the solution to this one is 1 over x to the 3rd. And here's why. Remember, it's in the first one it was 4 minus 2. It's the power in the numerator minus the power in the denominator. So this one would be x to the 3rd minus 6 power. And 3 minus 6 is negative 3, so this would simplify as x to the negative 3rd power, which, if you remember, x to the negative 3rd power is 1 over x to the 3rd power. So both of these answers would be a good version of a simplified form of x to the 3rd over x to the 6th. So in the example above, we take the power in the numerator and subtract the power in the denominator. So b to the m over b to the n is b to the m minus n power. And you can write it two ways, as a negative exponent or as a fraction exponent. In this case, the exponent would be in the denominator of the fraction. The last property looks at what happens when you raise a power to a power. To raise a power to a power, keep the base and multiply the exponents. Multiply the exponents. So 9 to the 4th to the 5th power is 9 to the 4th times the 5th power, or 9 to the 20th. So let's take a look at 7 to the 3rd raised to the 2nd power. So this would be 7 times itself 3 times raised to the 2nd power. So if I take what's inside the parentheses and I raise it to the 2nd power, it means I'm going to multiply it by itself. So it would be 7 times 7 times 7 times 7 times 7 times 7. That's right, it would be 6 sevens. In other words, 7 to the 6th power. So how did I get 7 to the 6th power with the raising a power to a power? So 7 to the 3rd power raised to the 2nd power is 7 to the 3rd power times 2, or 7 to the 6th power. So let's look at that algebraically. X to the 5th times the 10th. It's x to the 5th times 10th power. So this would simplify to x to the 50th power, because 5 times 10 is 50. And x to the 2nd power raised to the negative 5th power would be x to the 2nd power times the negative 5th power, or x to the negative 10th power. So anytime you raise a base to a power, like b to the m, and you multiply it by another exponent, you simply multiply the exponents to get the new exponent. That's raising a power to a power. Okay, now you try. Click pause and try these problems, and click play to check your answers when you're done. Make sure you copy the problems and solve them accurately, and when you're done, click play to check the answers and self-assess. Good luck. So in number 1, you're multiplying two powers that have the same base. If you remember, you simply add the exponents. So this would be 5 to the 6th plus the 9th power, or 5 to the 15th power. So number 1 is 5 to the 15th power. Number 2, I'm multiplying powers with the same base. So I'm going to add the 5 and the 6. So I would get x to the 11th power. Remember, check your answers. Number 3, when I'm dividing powers, I subtract the exponents. So this would be 6 to the 5 minus 3rd power, or 6 to the 2nd power. If you wrote 36, you wouldn't be wrong. You simplified it one step further, but 6 squared would have been a good answer. Number 4, I'm dividing powers again, and when I divide powers, I subtract the exponents. So this would be a to the 3 minus 5th power, or a to the negative 2nd power, which could also be written as 1 over a to the 2nd power. So if you have either one of these answers, you have a good simplified version of this. Number 5, multiplying a power times a power, you leave the base the same and you multiply the powers. So this would be 3 to the 20th. 3 to the 20th. Number 6, 4 to the negative 2nd power raised to the 3rd power would be 4 to the negative 6th power, or 1 over 4 to the 6th power. Either one of these answers would be good. How'd you do?